2011 Form A FRQ for BC, question number 6, the Taylor series one. So they give you a graph of the fifth derivative. Probably going to use it somewhere, so keep that in mind. So they tell us there's a function f of x, which is the sine of x squared plus cosine of x. And then it says write the first four non-zero terms for sine. Sine x, you should have memorized. If you don't, that's muy bad. Sine of 0 is 0. So you know when you plug in 0, you should get 0. So it shouldn't start with 1. It should start with x, which will give you 0. That's an odd power, so it alternates. That's going to be third over 3 factorial. Plus, it's going to be odd power, so fifth over 5 factorial. And they want the first four non-zero terms, so we're going to go minus x to the 7th over 7 factorial. Do they want the general term? I guess not. So that's going to be it for sine x. Then what for sine squared? This is going to use one of the 5 things you can do to a Taylor series. So you can replace x on the function and the series with a new function, which will be x squared. So let's do that. Now, one side note, that answer I left there is not sufficient. That is not the form of a Taylor series. You shouldn't have a power to a power. It should just be a single power. So we need to simplify this and rewrite this like such. X to the 6th over 3 factorial, x to the 10th over 5 factorial, x to the 14th over 7 factorial. That is a proper form. So part B, I hope I left myself room. Write the first 4 terms, non-zero terms for cosine. So this is something that needs to be memorized. Cosine of 0 is 1. So you need a 1. That's x to the 0, which is even power. It alternates. So it's going to be x squared plus x to the 4th minus x to the 6th plus dot, dot, dot. So that's cosine, but what do they want? They want the series for what? F. F is sine plus cosine. That's the other thing we learned that you can do to Taylors. If you have 2 Taylor series, if you want the function for the sum of the 2 functions, you just sum the 2 series. So we are going to do that. I'm going to put sine x squared first, which I found in the last problem. And then I'm going to add that to the one I just did, the cosine. I'm just copy and paste that because I am lazy like that. Copy and paste is my friend. Look at that. That's beautiful. And what do they want? They say they want the first 4 non-zero terms. So we're going to add these. So we're going to start with a constant 1. And then x's. Notice there's 2 of them. No x's, I mean. Notice, whoa. Okay, I think we're good. There's no x terms, so we're going to do our x squareds. So it's that plus that. But we need to combine those. So I'm going to factor out the x squared. And what does that leave us? 1 minus 1/2. Where'd that come from? It's 1x minus 1/2 x, or x squared. So we're going to get a half there. Then, for our next term, it's going to be x to the 4th over 4 factorial. And then the next will be x to the 6th, but we have 2 of those. So I'm going to factor out the x to the 6th, and we're going to have 1 over 3 factorial minus 1 over 6 factorial. So they're both minus, so I took the minus out. It's 1 over 3 factorial and 1 over 6 factorial. Oh, that should be plus because I took the negative out. Since I took that negative out in front, that becomes a plus. You can simplify that, but not necessary. That is my answer to part B. Part C. Okay. This is the very important one. You need to be careful about how you find this. I warned you in class, you do not want to be taking the derivative of this 6 times. Part of it because you have a plus dot dot dot. And so you'd only be taking the derivative of a portion of f, not all of f. And therefore, you got to be careful how you word your answer and how you do that. And it becomes kind of tricky. But it's doable. You can. It's just a lot more work. But here's the way you should do this. You should realize the 6th degree term of a Taylor polynomial is formed by the 6th derivative at the center times x minus the center to the 6th power over 6 factorial. That's how you find the 6th degree term. But there is a 6th degree term right there. That must be the same because that's how you form it, and that's what it is. So we set this equal to our 6th degree term. And then that cancels with that, and we're left with this. The 6th derivative over 6 factorial is negative 1 over 3 factorial plus 1 over 6 factorial. But to get this all by itself, you multiply both sides by 6 factorial. Those cancel, and now you have the 6th derivative at 0 as this. Now, again, could you simplify? You can, but you shouldn't. I would leave it like this. If you do simplify, do you want to do for fun? I mean, we could. Don't do this at home. Distribute that there. You're going to get negative 6 factorial over 3 factorial minus 6 factorial over 6 factorial. So that minus gets distributed and the 6 factorial gets distributed. And you're going to be left with on top 4, 5, 6 minus 1. All over, not over anything. That's it. That's going to be 120, negative 120 minus 1, negative 121. But why do that? That's the right answer, but why? Why would you do that? Okay, part D. Let P4 of x be the 4th degree Taylor polynomial using information from the graph. We want to show the error. So this is the actual value of the function. This is the Taylor polynomial. And we subtract it, it's the error. So I can just say, what will the error be? And according to Lagrange, because this is not an alternating series, if you take a look, plus, plus, minus, that's not alternating. So it's not an alternating series, so you can't use the alternating series error bound that we learned in chapter 9. The only thing we left is Lagrange, and the error is less than or equal to, and you want the maximum of the next term to be safe. And so what is our C going to be between? We're centered at 0. We're approximating at 1/4. So our C must be between 0 and 1/4. And we have to get, okay, so this is the 4th degree being used. So we need to use the next unused term, which is the 5th degree term, which is going to be the 5th derivative at some point C times x to the 5th power. But x is 1/4, so it's just 1/4. I'm just putting 1/4 there. You don't need the absolute value on it in this case because 1/4 is positive, and that's all over 5 factorial. Now, here is where the trickiness comes. The 1/4 to the 5th, that's easy. That's just 1/4 to the 5th. The only tricky part is what do you put in for the fifth derivative? You want a number that's bigger than that can be. Well, c is from 0 to 1/4. If you look at this graph, there's 0, there's 1/4. And your function, your fifth derivative takes on those values. So the maximum of the fifth derivative looks right around there. But the question is, what is that? Is that 35, 36, 37, 34? That's 20. There's 30, 32. Now, you could pick any number that's safely above that value, but the easy one's 40. That's definitely above. So if you put a 40 here, what you're saying is this is less than 40, which it is, so we're good. Now, the only thing is, if you pick 40, that better be less than 1 over 3,000. You can calculate it, but I assure you it is. So we can stop there. If it wasn't, like say you had time and you actually calculated that, and it's not less than 1/3000th, you could put a 39 here to make it work, or 38. Just pick a number that makes it work, but 40 works. That's it.